In this video, we'll look at the 6 trigonometric functions, and we'll look at how they're defined with the inputs being acute angles. Okay, but before we do that, I want to take a moment to remind you of the sort of standard for how you write functions, the typical function notation. Okay, so the typical function notation would take a function like that's named something like f and input to it something called x. And so f is the name of the function name, and x in parentheses here is the input to that function. And the way to read this is f of x. Okay, so our trig functions have specific names. So let's look at the trigonometric functions here. F is sort of a generic name, right? And so we have 6 trig functions, and we'll start with the 3 basic ones. Sine is the name of a trig function. Cosine and tangent. We'll start with these 3 basic trig functions. Okay? And the names of these functions, the way you write them, you don't use a letter like F, you use an abbreviation for sine, cosine, and tangent. So for sine, you use the abbreviation sin. Cosine, you use the abbreviation cos, or cos. And tangent, you use the abbreviation tan. So we use 3-letter abbreviations for the trig functions. These are the function names. These behave like f. Now, the input to a trig function, we don't use the variable x, because as we said here in the title, inputs to trig functions are angles. So we don't use the variable x. Instead, since the input to a trig function is an angle, we typically use Greek letters. Such as theta, phi, sometimes called phi, alpha, or beta, maybe. Okay, those are common Greek letters used for inputs to trig functions. Now let me show you what they look like. So theta looks like this, phi looks like that, alpha is this, and beta looks like that. There are other potential variables, Greek variables you can use for inputs to trig functions, but these are very common. And perhaps the most common maybe is theta. That's what I will tend to use most commonly. Okay, so now, just like with our function notation, we need a function name, which, for example, in sine we already have, and then in parentheses next to it I need the input, right, just like the x up here, but instead of x I'm going to use theta. So I have sine of angle theta, or cosine of angle theta, or tan of angle theta. And that's the function notation for those 3 trigonometric functions. Now, how are those trigonometric functions defined? So let me just make a note here. Note that for this video, we assume theta is an acute angle. Okay, we're only defining the trig functions if the input is an acute angle. All right. So, how are these functions defined? And that's where up at the title of the video you saw the acronym SOH CAH TOA. That's a mnemonic device to help you remember the definitions of the trig functions, how the ratios work. So I'll write that here again. SOH CAH TOA. Okay? So when you see SOH, you might realize that the S is for sine, and the C in CAH is for cosine, and the T in TOA is for tangent. Okay? So the OH, AH, and OA, those are relative to a right triangle. So if I want to know the sine of angle theta, this acute angle theta, what I need to do is construct a right triangle that has that angle as one of its acute angles. So here we have a right triangle, and let's say that this angle up here is our angle theta that we're interested in, this acute angle. Notice that both of these other angles, besides the 90, has to be acute. All right, so now what we need to do is take this triangle and label the three sides relative to this angle theta. Now there's one side that's always consistent. The side that's opposite your 90-degree angle is your hypotenuse. Okay, it's always opposite your 90-degree angle. The other two sides are called the adjacent and opposite sides. So here's theta. The side that's opposite theta would be, in this case, the side on the bottom of the triangle. So this is the opposite side of theta. Okay, so you label your sides in relation to the angle you're working with. If theta were here, the vertical side would be the opposite side. Okay, so it just depends on where your angle is. Then the side that sits next to the angle theta is called the adjacent side. So this is the adjacent side to angle theta. Now, if you notice, theta has two adjacent sides, right? This side and this side. That's why it's important to first understand where your hypotenuse is. Your hypotenuse can never be considered as the adjacent side because it's already reserved to be the hypotenuse. Okay? So we've got our sides labeled, and now hopefully you can see that the O and the H, the O, the A, and the H all stand for opposite, adjacent, and hypotenuse. Okay? All right, so now we're getting closer to defining what these trig functions mean. One thing I want to point out is that it's very common when you write the sine of theta, because for whatever reason we try to take shortcuts wherever we can in notation, because after a while it becomes cumbersome. So since these functions are named with words as opposed to being named with a letter like f, since these functions are named with words, what we do is we typically don't write sine parentheses theta for sine of theta. We typically write sine theta with no parentheses. It still means the same thing, but we don't need the parentheses necessarily because the word sine separates it from the input theta. If you were to do that above with f, it would look like fx. And since f's a letter and x is a letter, there's no distinguishing between those, okay? So very common not to use the parentheses on the trig functions. I recommend using them for a while when you're first learning to get used to them. Nonetheless, what is the sine of theta? What is the output of this function? Well, the output of this function is based on SOH. And each of the outputs of the three trig functions I have listed here is a ratio, a fraction. So O and H means opposite hypotenuse. And if we turn that into a fraction, it's opposite divided by hypotenuse. So to calculate that, you would go to the right triangle, you would take the length of the opposite side, and divide it by the length of the hypotenuse. That fraction would be the output of the trig function sine of theta. Okay? So the input to a trig function, is an angle. The output of a trig function is a ratio. And you could even say of two sides. All right, and that's what we're looking at for now. Okay, very good. Let's do the same thing for cosine and tangent. So cos theta, you don't need the parentheses either, and cos is CAH, so you can imagine the ratio will be adjacent over hypotenuse, the AH part. So the adjacent side divided by the hypotenuse. And then we can do the same thing for tan. Tan is TOA, OA, so opposite over adjacent. Okay? And that's how the trig functions are defined. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. SOH CAH TOA. Okay, so I said before at the very beginning of the video that there are 6 trig functions, and we only have 3 here. So let's go down and see the other 3. So I've listed the 3 trig functions that we've seen already, and I'm going to list the next 3. We have cosecant, we have secant, and we have cotangent. Okay, and we need to use 3-letter abbreviations for each of these functions. Since COS is already reserved for cosine, cosecant uses CSC. Secant is SEC, and cotangent is COT. Okay, the input again is the same angle, same acute angle theta, which we had listed in our triangle. And the output of these 3 trig functions are the reciprocals of the ones we see above. So the cosecant of theta, the output of that is the reciprocal of the output of sine theta. So these 2 guys are reciprocals, sine and cosecant. That does not mean, by the way, that's not the same thing as sine to the negative first of theta. This is something called an inverse trig function that comes later down the road. Okay, so you'll see on your calculator probably a button like this, and that's not that this -1 exponent here does not mean reciprocal for trig functions. All right, and then we have 2 other reciprocals. So secant of theta, the output of that is going to be the reciprocal of cosine of theta. And cotangent would be the reciprocal of the output of tan theta. Okay? So if you wanted, you could come back and you could say, well, the reciprocal of sine theta would be, if I flip the fraction over, it would be hypotenuse over opposite. That's true, but I don't think it's valuable to memorize that. I think it's valuable to always think of cosecant as being the reciprocal of sine, secant as being the reciprocal of cosine, and cotangent as being the reciprocal of tangent. So let's look at the reciprocals, the reciprocal pairs. Okay? So we have sine, cos, tan. Okay? The reciprocal for each of these, well, the reciprocal for sine is cosecant, as we saw before. Reciprocal for cosine is secant. Reciprocal for tan is cotan. Okay? Now, what I want you to notice is, if you look at each of these pairs, like sine and cosecant, notice that this pair has a co. Sine does not have a co, but cosecant is a co-function. Look at this pair. Cosine has a co. Secant does not. Okay? Cosine is a co-function. Tan and cotan. Cotan is a co. Tan is not. So each pair has one co-function. Okay? So I think that's important to know it. It's a way to help you remember how the pairs match up. In another video, I will show you how to use these trig ratios to actually calculate things.